Right. So I have a question for, I'm trying to pronounce the name. I'm going to be, I have a question for Surisetti. I do apologize if I pronounce it wrong. It's a gentleman who presented on the intercomparison in the Indian Ocean.
Yeah, Arun. Yeah.
Yeah.
Oh, sorry. Is he around or?
Arun is not
you.
there.
Hi.
Maybe, I'll try to answer. Yeah, please go ahead. Yeah.
Oh, okay. So I just want to kind of clarify a couple of things, because I think in the slide with the table, I think he mentioned that all the participate L4 are using optimal interpolation, but then in the later results, it seems to showing result coming from 2021. So I just want to say for at least for the Met Office products, 2021, the data wouldn't be using the optimal interpolation. So if he's particularly interested in the OI's impact, then would have to be using data from before 2018, February 2018. So that's just clarification point. And I would also highly encourage if it could repeat the same comparison using, well, I guess either just clarify which particular products are used, or because I think from the results, it's more likely that the Met Office product is actually the NemoVar version, and it's a lot more recent than the OI and some and some of the participating products in the OSDA is also not the most up to date, because I don't see SSTR and AATS obviously has been discontinued long before 2021. So just kind of clarify the details.
Yeah. So the UK Met Office, this OSTIA product that has been used, and for the JPL, it is the MUR product, L4 MUR product.
Yes, but the result coming from, is that from 2021, the results you show? Yeah, but if it's near real time Met Office OSDIA, then it wouldn't be OI, because we discontinued OI version from February 2018. So that will be NemoVar. So if you're interested in OI impact, then it will have to be looking at a period that's before February 2018.
Okay, fine.
Thanks.
Did you catch that? Because I'm going to ask you later for the minutes. I'm not able to write it here. Okay. We see a hand raised.
Yeah, hi, Jakob from DMI. Just want to comment on, well, it was very interesting presentation by Arun. I agree. Just want to comment that on the DMI results, there were a few corrupted files in July in that year. It's stated in the GIMP intercomparison side, so that might be the reason for this for these results you'll see. And I'm wondering if well, first of all, if the presentation is available. I think it's interesting. Okay, great. And also if you have plans to look at more than 1 year. Excellent. Thanks.
Yeah, there was like a deja vu a little bit. In 2015, I remember we had found some corrupt files in DMI. You may not remember, or may do. That was Aztec, right? Yeah.
Sir, Neeraj sir. Sir, this question is again to Arun Kumar in the study, sir. So you people also did some validation with respect to with NovaIQM dataset, right? In the study.
Yeah.
So what is the collocation criteria with respect to time of measurements? Any collocation criteria kept?
Yeah, means we intercompared the daily averaged data, because this GRIS products were daily averaged. Sir. So we averaged the IQM datasets on a daily temporal scale.
So for every grade, you took all the data measurements within the 24 hours and you have averaged?
That's right.
Okay, but is it right?
Means what could be the other way?
No, I'm just asking, because normally when we do validation, we try to do at L2 level. And we also put very stringent criteria in terms of time of measurement between the two, like the time of measurement from the satellite as well as from the in situ site.
But we are comparing here the L4 products which are available at daily resolution. Yeah,
I understood. I'm just asking. I want to know your point on in that way.
Yeah, means we have seen the other validation results also where this time collocation is also taken into account. But as a user, you know, I'm getting the L4 product, right? So how does it compare with the observations? That's what is the objective.
Okay, sir.
I can answer his question actually. So actually the analyzed data sets are foundation SST. As we all know, foundation SST have very negligible diurnal variation. So that's why we can take an average of all the in situ data available at that particular day. So that's why we got these results. So we initially thought of limiting our validation data sets from in the evening, means where the solar insolation effects will be negligible. Later on, we found that this is a foundation data set. So these corrections means this inclusion or exclusion of the data sets is not that much necessary. Anyway, we are going to work further on this, how the impact of daily average as well as the timely average on this validation data sets. Thank you.
Yes, thank you. Yeah, I'll just respond to that point because one would never use day and night buoy data, drifting or mooring data to validate L4. You don't use the daytime because drifting buoys are 20 centimetres roughly in depth. They actually experience quite a lot of diurnal warming in low wind speed, high sort of insulation conditions, and certainly over the tropics. The tropical moorings have been used to study diurnal warming. So again, you know, we always use the nighttime observations under well mixed conditions, you know, higher wind speeds for validation. I'm not sure if you chose the high wind speeds, did you, with
we have
your
not,
validation?
That part we have, we are supposed to do that.
Yeah, sure. Okay.
We will do it, yeah.
The other point is that we've had a number of really interesting talks in this session, and it just struck me that we have, some of them have used sail drone data, which is independent of any of the products that have been assessed. I mean, sail drone is nice in that you are absolutely certain that it has not been assimilated into any of the satellite SST analyses of products that you are trying to validate. So at least you know that because it's not on the GTS. The other one was Hai Fong's presentation where he used independent skin SST from a ship, again, to validate satellite SST that has never seen skin SST from a ship. So it's totally independent. You know, we've been going on for what, 23 years now in CRIST. And for years, you know, we were saying, do not ingest Argo SST into your level 4 product. And we all agreed to do that, and then people forgot, unfortunately. Some people, they weren't at those meetings or whatever, and they went, oh, actually we have ingested Argo SST. And that means that it no longer is a quality, independent, QC'd in situ SST data set that can be used for independent validation. And that's why we're just going around round and round and round in circles going, can we use GIMPy? Well, we thought we could use GIMPy and we still do. And maybe, as John Zhang and Boyan Huang has said, perhaps it's not such a great idea, but there is no perfect solution unless you have independent in situ data. Now, India has a number of coastal moorings. I don't know if they're on the GTS or not. I think I've already spoken to a gentleman this week about independent coastal in situ SST from tide gauges, wave buoys, you know, platforms that we absolutely know have not gone into any of the L4 products. So just be very, very careful when you choose an in situ data set for validation of satellite SST products. Just check, has it gone into the L4 product at very high weight? Because the buoy data from drifting buoys and tropical moorings, that is given the highest weight in every L4 product except CCI and NOAA Geopolar Blend, which do not ingest any in situ data. Others, it is used for bias correction. It is given the highest weight in the OI. You can see if you do a difference, between an L4 product and the tropical mooring SSTs, it's just almost 1-to-1. It is almost exactly the same on that day. What is the point of using drifting buoy and tropical mooring data to validate any L4 product where it has been used so incestuously to ground truth the satellite SST at that point? That's all. Just be careful. Think before you choose an in situ data set. Yep.
So just to respond to your comment, Madam. So you said that it's not right to use the drifting mode data during daytime for the validation studies, right? But by considering wind speeds also over very high wind speeds, we can use, right? No?
Yeah, it depends on the producer, how they quality control their in situ data. At the Bureau, I wrote the code, so I know that I reject any in situ SSTs, including from tropical moorings and drifting buoys, during the daytime for wind speeds greater than 6 metres per second. That's from NWP winds, and at night time greater than 2 metres per second. So I guess those are ones, you're right, actually, they would not have gone in.
I did one sensitivity analysis with respect to the time differences with respect to wind speed. I found more than 6, it is very negligible in terms of the differences, both for the night and daytime. And actually it is present in my poster, I'll definitely show it to you.
I'll see your poster because you have brought up a really good point. Now, I know what I do to in situ data. I don't know what other people do. I think that the OISST v2.1, because it's day and night, it's not a foundation SST, it's a blended product. So they give just as much weight to daytime data as nighttime data. They don't look at the wind speeds, they just ingest all day and night data. And that includes the in situ data. So that means that for OISST, they would not have used wind speed to QC the in situ obs that go in. So yeah, it's yeah. So you've got to understand how the L4 product is being produced, so you can validate it, I guess.
Thank you, Madam, for the detailed answer.